Object-oriented development can be a challenge to anyone new to the PHP programming language. It's a new way of thinking about how to write software. It's very powerful in that it allows us to encapsulate, to enclose the data and the behavior that acts on that data into a software construct that we can use throughout our application and in fact share it with other developers so that they can use it within their applications. Object-oriented development is the epitome of software reuse. In object-oriented development, an object represents a thing, a concept within our application. Those things have attributes or properties that define their being. We refer to that data that we enclose within this software construct as attributes or properties of the object. And we typically do not allow users of our objects to interact directly with the data. Instead, we define functions that allow certain behaviors of the object with which a user of the object can interact. So another advantage of objects is that they have a very clearly defined interface for their use. So if we're a user of an object that performs some complex task for us, then we can focus on building our application without concerning ourselves about the complexity of the implementation of the thing that the class is doing. The class will generally have a well-defined interface with which we can interact. And so long as we understand how to use the interface, which is simply function calls, then we can take advantage of the functionality of the object without really understanding how it is that it does what it does. So when we create an object, we say that we are instantiating the object. That is, we are creating an instance of the object. If we have a class definition, we may have many objects that are created from that class definition. The class definition creates in the PHP system a fully fledged variable type within the system. With object-oriented development, our thinking about software changes dramatically. It's a sea change, a paradigm shift in the way that we view software constructs within our applications. When we're designing an object for our application, we're in search of nouns, things that are in our system. Those things typically have behaviors. Behaviors can be described using verbs. At any point in time within the execution of the application, an object will have a state of being. And that state of being is defined by the values of the data that are encapsulated within the object. So a classic example of a thing, an object in an application, is a person. The object has data that defines it, and we've listed some data here that defines a person: age, height, gender, and so forth. Those are the attributes or the properties of a person object. Then the way that we interact with this object is defined in the set of behaviors that we as developers provide for that object. In this case, we provide an interface to each of the attributes of the object, the ability to set or to get the value of those attributes. That is the behavior of the object. Throughout our exercises and demonstrations, we've been working with a user and logging that user into our application. As an example of how we might create an object, we will create a user object that encapsulates the data and the behavior that we might need in our application. So recall that when we define the object, the class, for this user type, it becomes a template within our application from which we can create specific objects of type user. So some of the attributes that I'd suggest for our user class are the username and password. maybe a user ID, an email, maybe a secondary email, and the status of the user, whether they're an active user or inactive user. Some of the behaviors that might be appropriate for a user object is to log in, to log out, to send an email to the user, to change the user's status, or to log a user's visit to our application. An object definition is subjective. There is no right or wrong. So let's look at the syntax, the rules within PHP that allow us to create these classes for our applications. When we're defining the encapsulated data, the attributes and properties of the class, we have the same naming restrictions that we have with variables. And although not enforced by the syntax, a good design practice is to never allow direct access to any of the object's internal data. Therefore, all of the attributes or properties of a class should be marked as private, prohibiting direct access, which leads us then to defining behaviors. We want to define behaviors that make our object easy to use, flexible, and complete. When we're defining behaviors, we also have a choice of whether or not to make that behavior publicly accessible, that is, accessible by the user. There are occasions when we will define internal behavior for an object that should not be accessible by the user of the object, but is some function or some behavior within the object that we need to use to manipulate the state of the object, but not to allow a user to call that function. There's 4 steps to creating a class. First, we have to sit down, before we write any code, we have to sit down and think about what are the properties or attributes of this class, and what are the behaviors that I'm going to define for the class, this interface for the user. Then what access levels am I going to provide for this behavior? Then we need to decide how we're going to construct these objects. What is necessary to make an object of this type? And then finally, when the object is no longer needed, we need to define how the object should release any internal resources that it needs to release, and define a destructor for the object. Notice that PHP defines a constructor and a destructor for us. We don't have a choice of naming the constructor and the destructor. In PHP, when we want to provide a definition for how an object is to be constructed, what state it is to be in when it is created, we write a construct function. A construct function is 2 underscores, the word construct, and parentheses. The code block that follows the construct function defines how the object will be instantiated. What state will the data be put in when the object is created? And likewise, for the destructor, PHP defines this function for us, 2 underscores and the word destroy, followed by the parentheses. The constructor and destructor are both simply functions, but they're special functions associated with our object. The code block that follows the destroy function will be executed when the object is no longer needed. We would put code in this destructor method that would release any resources that needed to be released before the object is destroyed. So we've got a definition of an object, either ours or someone else's that we're using, and we want to create an instance of that object. We want to instantiate an object of that type. We have a new keyword, literally a new keyword. The new keyword tells the PHP preprocessor this is an object and we need to create an instance of this object. This is the name of the object, and here are the values that it needs to create itself. Go create it for me, And when you're done, give me a handle to that created object, and I'll store it in this variable. So we've kind of seen this already. If you'll recall from the demonstrations, when we were throwing a new exception, we were actually creating an object of type exception and then throwing that into the try-catch mechanism in our code. This is very similar. We are creating an object using the new keyword. The PHP preprocessor actually creates this software construct for us and then passes back a handle to that object that we're storing in this case, the myObjectVar variable. Now we want to interact with the object, the behavior in the object. We have another new operator. Although we've seen this before, in this case, the arrow operator, which is the minus sign and the greater than symbols, allow us to call the internal behavior of an object. In the example here, we have an object that has a function within it called do something. Now we've created the object with the new keyword, and the handle to that object is stored in myObjectVar. So using that handle, myObjectVar, and this new operator, I say call this behavior do something. Now again, we can control the accessibility of all of the internal attributes and behaviors of an object by using these three new keywords. An object would not be very useful if it had no public behaviors, so keep that in mind. But on the other hand, we want to protect the state of the object, to not allow a user of the object to be able to put the object in a bad state. So there are things that need to be protected, there are things that need to be public, and as the designer, as the developer of the object, we need to make those informed decisions. So the three new keywords are public, private, and protected. Any attribute or behavior that you adorn with the public keyword will be accessible to anyone that uses the object. Any behavior or attribute that you adorn with the private keyword will be inaccessible to anyone using the object. And the protected keyword will only allow access from a subclass of this type. We're going to talk about inheritance and subclasses in the next video. That's where the protected keyword will become useful.